Okay, so in this video, we're going to be reviewing atomic structure. So in an atom, you have a variety of different subatomic particles. Specifically, there's three that we're going to be talking about. In the nucleus, so in the very center, I'm going to circle the nucleus here. The nucleus is populated with protons and neutrons. And then surrounding the nucleus, you have electrons. What is important to remember about these is the charges associated with these. So protons are positive charge, electrons are a negative charge, and the neutrons have no charge. Okay, and then additionally, the nucleus is surrounded by electrons in a fuzzy distribution cloud. So you might remember that models such as the Bohr model, where it kind of looks like the nucleus is surrounded by planets, kind of like a solar system. That is not a correct model in order to think about what an atom looks like, but it's more an electron cloud, meaning that where all of these little dots are in this picture is predictions that one specific moment where the electron might be. So it's more densely populated in the middle and kind of disperses out like a cloud. Continuing on, we have atomic structure. So what are the properties of each of these subatomic particles? So proton, neutron, electron, as we just talked, the charges are very important to protons, neutrons, and electrons, and that protons are a positive charge, neutrons are neutral, and electrons are -1 or negatively charged. The mass of each of these particles is also important. So I show the actual mass on the side here, and you can see they're really, really small. But what is really important to notice is that the electron's exponent here is much smaller than, or larger in terms of more negative, than the exponent for both the proton and the neutron. So relatively, proton and neutron are the same mass, whereas an electron is much, much smaller than that. So overall, relatively, even if we had a ton of electrons, they would not add up to really much of a difference in terms of relative mass. So the masses that we really need to remember are just 1 and 0 for each of these. 1 for proton and neutron, and 0 for electron. So when atoms have equal numbers of protons and electrons, they're called neutral, which contrasts with particles that have unequal numbers of protons and electrons, which are called charged. Additionally, charged particles have another name, and that they are called ions. So some examples of ions could be a chloride ion, where you have a negative charge on the chlorine. Could have sodium, for example. We can also have something like hydrogen, which has a positive charge typically, or bromine, which has a negative charge. So these are all examples of ions. Okay, and then looking at elements and their atomic number. So on the periodic table, you typically see symbols such as these. So you'll have a symbol in the middle, which represents your name of your atom. Sometimes you'll have your full name underneath it. So in this case, you have the name right here for what this symbol is. In the top left corner, we have our atomic number, which is our equivalent to our number of protons. So at the very top, we see the statement, an element is defined by the number of, which is protons in its nucleus. So it doesn't matter how many neutrons or electrons are in the atom, in terms of classifying it into which symbol or atomic number it is. It's the number of protons that determines what kind of atom that is. Lastly, on the bottom here, we have our mass number. So this is the number of protons and the number of neutrons added together. You'll notice that it's not exactly 1 or exactly a 1 number, since we just talked about the masses of protons and neutrons being relatively 1. And this is because of isotopes. So when you have more isotopes or more neutrons in some versus the other, you'll get a number slightly off of the exact integer mass number. So going through one quick example, we have carbon. So based off of this square that we have here, explaining what the properties of carbon are, our atomic number in the top right corner, I'll change some colors around. Atomic number in this top right corner is 6, as it tells us. Then we have our number of protons, which again is defined by the atomic number. So we also have 6. Our number of neutrons is going to be our mass number on the bottom, the closest integer, which is 12, and then we'll subtract the number of protons. 12 minus 6, which gives us our number of neutrons, which is also 6. And then lastly, we have an uncharged particle. So our number of neutrons is going to equal, our number of electrons is going to equal our number of protons. So we also have 6 electrons. So 6 down the line. Okay, so next up, we're going to do some practice with atomic structure. So I'll have that on another video for you guys to review.